Hello my dear guys, welcome to the video. Today in this video we are gonna be looking at how to find out the resultant of the forces, resultant of the number of forces which are being acted on a body. In our previous videos only we have looked at finding out the resultant for only two forces. Whenever a body is subjected to two forces, by using parallelogram law of forces we have found out the expression for the resultant as well as its direction. But what if number of forces acted on a body? So in this video we are going to be finding out the expression for the resultant and direction as well. Fine, let us go with an example and you will understand it a bit clear. Let us take a body. On this particular body, few forces are being acted. One in horizontal direction, which is of magnitude F1, and it is acting directly in a horizontal direction, and one force acting in this direction, which is making 60 no which is making an angle of theta 1. Let us say it is theta 1, and magnitude of this angle of this force is F2. F1 newtons, of course it is measured in newtons, and another force I'm taking it here, and this is making an inclination of theta 2, and another force from here which is making an inclination of theta 3, and the name of the force is F3. This is the diagram uh, when all these four forces are being acted on a single object. When all these four forces are acting on the single object at the same time, the body starts moving with a force. The body will attain a new force and it start moving in any direction. Any direction in the sense, in the direction in which direction the resultant goes, in that direction the object will also move. So let us try to find out the resultant. Fine, I'm taking another page. So first of all, what I'm gonna do is, for these all forces I'm going to represent all these four forces in a coordinate system, and I'm going to start all these four forces from a single point, that is nothing but origin. So let us draw a demonstration here. Right here I'm going to place all these forces one by one in this coordinate system, and the centermost point O, it is nothing but origin, and this is x-axis, and this is y-axis. So I'm going to represent forces one by one in this coordinate system. So this is force 1. What I'm doing here is I am starting every force from a single point, and the single point is nothing but the origin. So I'm representing this force now. From here I'm starting it, and what is the inclination? That is theta 1 with the horizontal. So theta 1, what is the name? F2, right? And third force, this force is F4 and it is F3, and this force which is acting in this direction, and the inclination made by it with the horizontal is theta 2, and another force which is acting towards down, and I'm taking it towards down direction. So whatever I'm representing in the coordinate system, I'm starting the force from the center, and I'm not pointing the center, but I'm starting the force at the center and I'm taking it to somewhere where it is up to where it is needed. So the angle made by the force F4 is theta 3. Angles numbers might be different, but it is just for representing you the direction, that's it. So this is how we are going to represent all these four forces in a single coordinate system. Let us do it in a fresh page. So here I'm gonna draw the coordinate system first, which is it is y-axis, and horizontally it is x-axis. So on this coordinate system I'm going to represent these forces one by one. If you wait, okay, fine. I'm going to represent our first force F1, sorry, F1 this way, F1. I'm going to represent our second force with a different color F2, which is making an inclination of theta 1. Let us choose another color. This is F3, which is making an inclination, sorry, an inclination theta 3. We have another force which is remained. So this force F4, F4, it is making an angle theta, no, theta 1 it is theta 2, theta 3 it is theta 2, it is theta 2, sorry. So it is theta 2. This is what the representation of all the four forces in a coordinate system. What we're gonna do is, here we have one force which is completely horizontal, and all the other forces which are neither horizontal nor vertical are represented in this coordinate system will definitely have one vertical component at the same time a horizontal component, right? So let us divide all of them taking a box. I will be adding another page. So let us find out. I'm taking all the forces in a sequence: force 1, force 2, force 3 and force 4. I'm gonna write the horizontal component here, horizontal component, and vertical component. So this will make a, let us make it a diagram, a box, a table. So this is nothing but for force F1, this will be the horizontal component and this will be the vertical component. In this way we are going to write each and every forces components. So let us take force 1. It is only having the horizontal component. It is nothing but directly it is F1. There is no component because it is completely vertical, so it will not have any component in its vertical direction. So it is directly having, F1 will directly have only horizontal component, that too it is F1 directly, F1, right? It is not having vertical component, so it can be 0. And go for second force, and for this second force it is making an inclination of theta 1. So for this second force the horizontal component will be F2 cos theta 1 and vertical component will be F2 sin theta 1. Let us paste this there. Horizontal component is F2 cos theta 1, F2 sin theta 1. These are nothing but the components, vertical and horizontal components. Let us go for the force, third force F3. So this F3 is having two components, horizontal and vertical. So what would be the horizontal component for this force F3? F3 cos, F3 cos, what is the inclination? Theta 2. So V equals to F3 sin theta 2. Let us write the same thing here. What is the horizontal component? F3 cos theta 2. Vertical component F3 sin theta 2. That's it. And we have another force which is F4. So for this force it will definitely have two components again. So what is the vertical component and horizontal components? Vertical component will be F4 sin theta 3. What is the horizontal component? F4 cos theta 3. So let us paste the same thing here. F4 cos theta 3, F4 sin theta 3. And this is all about the horizontal forces and vertical forces. So these horizontal components, if we add all these forces, all these forces can be represented in a single line, in a single force. As a single force in horizontal direction, we can represent the all these horizontal components, right? So in a single force, if we add up all these things which are completely horizontal, it can be, it will completely becomes a new horizontal force, right? It can be shown in a single force, shown as a single force. So if we add up all these vertical forces, all these vertical forces can be solely represented in a single, as a single force. It can be vertical components summation. So let us write this thing here, somewhat here. Here I am adding all these terms. What would be the summation of all these horizontal components? It can be, sigma h. Sigma h in the sense the summation of forces along the horizontal axis. So if we add all these forces, that would be the summation of all the forces in the horizontal axis. In the same way, it is sigma v. So sigma h can be represented as a single force which is in horizontal direction here. In the same way, sigma v also can be represented as a single force in a vertical direction here. So what I have done is I have converted the figure from, wait a second, let us go to the previous page. Previous page. So what I have done is I have extracted all the vertical forces and horizontal forces from each and every figure. So let us erase them all. I will so what I have done is I have extracted every horizontal component and every vertical component. So for this force F3, it is definite, it is sure that it will have a horizontal and a vertical component. I have divided both of them and I have given this vertical component to vertical axis, horizontal component to horizontal axis. In the same way, I have done it for all the three forces. And for the force F1, it is not needed since it is not having any vertical component, it is only having a horizontal component. So for every force which is having a horizontal and a vertical component, I have given the respective components to their respective axis. So for force F2, it is definite that it will have a horizontal component which I have given it to the horizontal axis, and vertical component which I have given it to the vertical axis. So for this vertical axis is now containing all the three forces, all the three vertical forces. So this force, and this force. So we also know that the forces which are acting vertically downwards can be taken as negative, and which are acting towards upward direction, those can be taken as positive, and the forces which are acting towards right can be taken as positive, and the forces which are acting left can be taken as negative. So let us also write the sign convention. So forces which are acting vertically downwards are taken as negative, which are going up can be taken as positive, which are moving left can be taken as negative, which are moving right can be taken as positive. This is nothing but the sign convention, right? This is nothing but the sign convention we have to use here. Which forces are moving down and which forces are moving up? Both F3 and F2 are moving in the upper direction. Wait a second. Here, which forces are moving in upper direction and which forces are moving in downward direction? So F3 and F2 are moving up and F4 is moving down. In the same way, which forces are moving towards right and which forces are moving towards left? F3 and F4 are moving towards left and F2 is moving towards right. F2 is the force which is moving right and towards up. F3 is a force which is moving left and up. and F4 is the force which is moving left and down, right? Right. So we will take all the forces along. F2 is the force which is, I will erase all this stuff. Wait a second. So here I will write down the directions inside the box. So Ft is the force which is the horizontal component is moving right and the vertical component is moving towards upward direction. Here for F3, which is moving towards left, the horizontal component moving towards left, vertical component moving towards upward direction. For force F4, the vertical component is moving down and the horizontal component is moving left. So let us sum all of them. So finally in sigma h, if I write sigma h, which is the summation of all the horizontal forces, for summation, for adding all these horizontal forces according to the direction, I have to add the sign. Thereafter I can add the respective signs like positive or negative. So what I have done is completely wholly what I have done is I have converted all the forces into vertical and horizontal forces, sigma h and sigma v. So here now we can apply the law of parallelogram of forces. Parallelogram law of forces. Here if we apply parallelogram law of forces, since we have converted all the forces into only two forces, that is only vertical and horizontal forces, by dividing or extracting the vertical and horizontal components, we have converted all the forces into only two forces. We have minimized the forces into two, since sigma v will have all the vertical forces and sigma h will have all the horizontal forces. So in that way what I have done is, here if I apply parallelogram forces, what happens is R equals to sigma h square plus sigma v square plus 2 sigma h sigma v cos theta, where theta is the angle between two forces. Here it is 90 degrees. Here it is 90 degrees. Since it is 90, this whole term will become 0 and the resultant expression comes out to be equals to sigma h square plus sigma v square. This is nothing but the final expression which we use for finding out the resultant when three or more number of forces are acting on a body, right? And we also have to determine the direction of the resultant. So for the direction I am considering, wait a second. So here it is clearly seen that if two forces like this are acting on a body, I have converted all the forces into two. If these forces are acting on a body, what happens? The resultant will be like this. So I am taking this force here, I am taking that force here now. So here, so and this is the resultant, that is nothing but sigma h square plus sigma v square. So the inclination made by it is nothing but the direction of the resultant. So the direction of the resultant can be found by using tan alpha. Tan alpha, it is nothing but, here it is sigma v, this length is sigma v and this will also sigma v. So tan alpha equals to, what is tan theta? That is opposite side by the adjacent side, that is nothing but sigma v divided by sigma h, which is the adjacent side, right? Here all we need is alpha. Alpha becomes tan inverse sigma v by sigma h. Here it is nothing but, it will give us the direction of the resultant. So the direction of this resultant it can be calculated by using this formula. By using this formula we can derive the direction of the resultant. This is what the expression. So I will also write the expression for resultant. R equals to sigma h square plus sigma v square. This is the expression for the resultant's magnitude and this is the expression for the resultant's direction. Hope you have understood the concept of resolving the forces. By resolving them, finding out the resultant of number of forces acting on a body. So soon in our upcoming videos we will be solving a problem, so you will understand this concept in a more better way. Thank you so much.